Hello dear students, welcome to Pen and Paper Chemistry on YouTube.
Hello dear students, welcome to part 6 of the series of videos on thermodynamics. Today we shall be introducing another thermodynamic quantity called as enthalpy. But before we do that, we shall pick up from where we left last time. We had spoken about the first law of thermodynamics and we had said that the change in internal energy is given by the sum total of the amount of heat absorbed or evolved plus the pressure volume work done. That means delta U is equals to Q plus W. U stands for internal energy, Q for heat, W for work. This is the mathematical representation of the first law. What happens if we talk about an adiabatic process, a process where heat remains constant? In this case, Q becomes 0. That means neither heat is absorbed nor evolved. In such a case, the thermodynamic equation for the first law changes to delta U is equals to W. Come to an isothermal process, a process in which the temperature remains constant. While doing internal energy, we had discussed that the internal energy of an ideal system varies directly as its temperature. If there is no change in temperature, there is no change in internal energy. Hence, delta U becomes 0. And our first law now changes to Q plus W is equals to 0. Third possibility, isochoric process. Isochoric means when the volume remains constant, there is no change in the volume of the system. Delta V is equals to 0. We know that we had derived an expression for work done as minus P delta V. Now delta V here is 0 as there is no change in the volume. Hence delta U becomes simply equal to Q. Now this Q is given a subscript V. Why? Because this is the amount of heat which is being absorbed or evolved when the process is being carried out at constant volume. This is another way of defining the internal energy change, because if you remember, we had said that we cannot determine the absolute value of internal energy. It is the sum total of all the energies associated with the system. We cannot determine how much is the internal energy of this whiteboard. We cannot. But when we carry out, when we subject it to some chemical change, it is the change in internal energy which can be measured, and this is equals to the amount of heat which will be absorbed or evolved when the process is carried out under constant volume conditions. So how do we measure this? We shall come to it a little later. Of course, it is written here using a bomb calorimeter. We also have an isobaric process. Bar is the unit of pressure. So isobaric process means a process which is taking place at constant pressure, not zero pressure. We're not talking about work done against vacuum. We're saying that there is no change in pressure. That means delta P is 0. Now, if you notice in the expression W is equals to P delta V, we are talking about the pressure. We are not talking about the change in pressure. Hence, our expression still remains the same. Delta U is equals to Q plus W. Coming back to isochoric process, that is, we talked about the measurement of the heat evolved or absorbed at constant volume. To determine this, we have a setup which we call as a bomb calorimeter. A bomb calorimeter simply consists of an insulated container inside which there is another small container, and this is called as the bomb. Why a bomb? Because it can withstand high pressure. In this, we have the reaction mixture. So let us suppose we want to determine QE when carbon is made to burn. So what is done is, we have the sample in the small container here. This is ignited with the help of the ignition wires, the fuse wires. And there is water in contact with this bomb. This water, because of the heat generated due to the burning of coal, will get heated up. Now, how does the coal burn? It is by the supply of oxygen. There's an oxygen inlet over here, and this burns due to ignition. So carbon plus oxygen gives you carbon dioxide. The amount of heat liberated heats up the surrounding water. In order to cause a uniform distribution of the heat, we use a stirrer. And in order to measure the change in temperature, we use a thermometer. The change in temperature is noted. Once the temperature becomes constant, this is now used to determine the amount of heat absorbed when this process has been carried out at constant volume. And how do we determine that QV? For this, we go back to our previous video where we had said that Q is mass into the specific heat capacity of the substance into the change in temperature. So Q is equals to mc delta T. We know the specific heat capacity of water, and we have, in this setup, we know the specific heat capacity of water. We have measured the change in temperature. We measure the mass of water before we introduce it into the vessel. So this helps us to determine the QV or delta U of this particular reaction. Coming to, calorie meter. Just break it up and this will help you to recall. Calorie is the unit of heat. Meter is measurement. That is why this setup is called as a bomb calorie meter. Coming to isobaric process, a process which is taking place at constant pressure. Now, most of the processes we talk about are taking place at constant pressure only because that's the atmospheric pressure, because it is not possible to generate or have a completely closed insulated container every time. We are carrying out the processes under atmospheric pressure called as constant pressure. So we shall modify our first law of thermodynamics equation. So delta U is equals to Q plus W. Since it is at constant pressure, there will be work of expansion. Delta U is equals to, because we are doing at constant pressure, we introduce the subscript P over here, minus P delta V. Delta U is equals to transition, taking it to the left hand side, we have delta U is plus P delta V is QP. Expanding the two. Delta U means the change in internal energy. So final internal energy minus the initial plus P. Delta V means change in volume. So final volume minus initial volume is equals to QP. U2 minus U1 plus PV2 minus PV1. Clubbing the final state values and the initial state values, we have U2 plus PV2 minus U1 plus PV1. Now, internal energy, again, it's a state function, but just now we said we cannot determine the absolute value of internal energy. We have another state function over here, which is represented by H. So, U plus PV is another thermodynamic quantity known as enthalpy. N means trapped, enthalpy means heat. That is the heat trapped in the form of internal energy, and the pressure volume work is what we call as enthalpy of a system. We cannot determine absolute value, so we cannot determine absolute value of H also. But you will realize that we don't need it also. Why? Because we just want the useful energy which can be used for our various processes. So, U2 plus PV2 is represented by H, and we will put the subscript 2 over here. U1 plus PV1 gives me H1. So we have H2 minus H1 gives us QP. That is, QP is delta H. So what is delta H? It is the amount of heat absorbed or evolved when a process is carried out at constant pressure. Because it's a new thermodynamic quantity, we need to introduce the characteristics. It's a form of heat, enthalpy. So the unit will be joule. It will be a state function because we know that it depends on internal energy. It is an extensive property. We know that heat depends upon the mass of a substance. We cannot determine its absolute value. How do we determine this QP? That means the amount of heat absorbed or evolved at constant pressure. Just now I mentioned that we are carrying out most of the processes under constant pressure conditions. So we can easily measure it by using an insulated mug. What we need to simply do is, we have an insulated mug which will not absorb heat itself. We cover it by an insulated container. We have the reaction mixture inside it. We just need a stirrer so as to allow uniform distribution of heat. We just need a thermometer in order to measure the change in temperature. Again, MC delta T will give us the amount of heat absorbed or evolved at constant pressure. To represent it diagrammatically, we have an arrangement where we have put stacks of insulated cups. There's an insulated cover on the top. We have the stirrer. We have the thermometer in order to measure the temperature change. So we simply call it as a coffee cup calorimeter. It's just a calorimeter which is measuring the amount of heat. Calorie is the unit of heat, so it is measuring the amount of heat under conditions of constant pressure. We shall be coming back to this equation again in the next video, and we shall be giving alternate forms of the first law of thermodynamics. In the meantime, please go through it, and the best is, if you can help out your peer group, if you feel benefited, please go ahead, help out your peer group, explain this topic to them, and you will find that it will embed better for you as well. Happy studying. Hope to see you in the next video.
The only mission of this channel is to make learning chemistry easy and fun for all you students, with the help of the periodic table, the flowcharts, the graphs, diagrams, dealing with numericals, how to deal with numericals. And this can only happen when you keep a pen and notebook ready, so that you can also take down notes for offline reference. There is no subscription to join the channel, there is no payment at all. Only request is to help spread a word about the channel by sharing it with friends, classmates, juniors, seniors, so that chemistry can be easy and fun for one and all. See you in the next video.